Hello, my name is Harsh Swaika and this is my ELP100 project on ignition system used in a car. So basically the modern car is a fascinating machine which relies a lot on the complex systems working together. One of the lesser known components of the petrol engine is an ignition system which connected to a spark plug is very essential for starting the engine. It works by creating a high energy electrical arc which ignites the fuel and gets the engine started. So basically an ignition coil or also called a spark coil is an induction coil in an automobile's ignition system that transfers the battery voltage to the thousands of volt needed to create an electric spark in the spark plugs to ignite the fuel. Some coils have an internal resistor while others rely on a resistor wire or an external resistor to limit the current flowing into the coil from the car's 12-volt supply. The wire that goes from the ignition coil to the distributor and the high voltage wires that go from the distributor to each of the spark plugs are called spark plug wires. Originally, every ignition coil system required mechanical contact breaker points and a capacitor condenser. The basic principle of this utilizes an RLC circuit. So brief history, in 1860, Etienne Lona used an electric spark plug in his gas engine, the first internal combustion piston engine. Lenoir is generally credited with the invention of the spark plug. Early patents from the spark plugs included those by Nikola Tesla, Frederick Richard Sims, and Robert Bosch. Only the invention of the first commercially viable high voltage spark plug as part of a magneto-based ignition system by Robert Bosch's engineer Gottlob Honnold in 1902 made possible the development of the spark ignition engine. So the structure of an ignition system, formerly ignition coils were made with varnish and paper insulated light high voltage windings inserted into a drawn steel can and filled with oil or asphalt. Coils on modern automobiles are cast in filled epoxy resins which penetrate any voids with the winding. A modern single spark system has one coil per spark plug. To prevent premature sparking at the start of the primary pulse, a diode or secondary spark gap is installed in the coil to block the reverse pulse that would otherwise form. So the basic principles which are utilized in this ignition system are the LC circuits, the Faraday's law of electromagnetic induction, and the principles of transformers. So basically by Kirchhoff's laws, we can derive the equation for the current and voltage in an LC circuit. By Faraday's laws of electromagnetic induction, the electromotive force around a closed path is equal to the negative of the time rate of change of the magnetic flux included by the path. For a loop of wire in a magnetic field, the magnetic flux phi b is defined for any surface sigma whose boundary is the given loop. Faraday's law states that the EMF is also given by the rate of change of the magnetic flux, which is E is equal to minus d phi by dt. So the ideal transformer equations by writing Faraday's law of induction gives us the ratio that the voltage is directly proportional to the number of coil turns. So basically now moving on to the working of an ignition system, an induction coil consists of two coils of insulated wire wound around a common iron core. One coil called the primary winding is made from relatively few turns, tens or hundreds turns of force wire. The other coil, the secondary winding, typically consists of up to 1,000,000 turns of fine wire. An electric current is passed through the primary, creating a magnetic field. Because of the common core, most of the primary magnetic field couples with the secondary winding. The primary behaves as an inductor, storing energy in the associated magnetic field. When the primary current is suddenly interrupted by opening the switch, the field in it rapidly collapses. This causes a high voltage pulse to be developed across the secondary terminals through EMF. Because of the large number of turns in the secondary coil, the secondary voltage pulse is typically many thousand of volts. This voltage is often sufficient to cause an electric spark to jump from an air gap separating the secondary's output terminals. For this reason, induction coils are also called spark coils. So initially no current can flow through the fuel and air in the gap is an insulator. But as the voltage rises, it further begins to change the structure of the gases between the electrodes. Once the voltage exceeds the dielectric strength of the gases become ionized and the ionized gases becomes a conductor and allows the current to flow through the gap. Spark plugs usually require up to 12,000 to 25,000 volts or more to fire properly, although the upper limit could be up to 45,000 volts. So these are the references I used in making my project. Thank you.